So for your first notes video, you're working with your template 3.3, solving equations with variables on both sides. And our goal will be to solve equations with variables, our letters, on both sides of the equation. So make sure you have that notes template out with you, ready to go. When we're solving an equation and we have variables on both sides or constants on both sides, we need to make sure we're choosing a side for variables. So you want to make sure you choose a side for variables. And of course then the other side would be for your constants. And it doesn't really matter which side you choose, you just want to make sure you make a decision so that you're not going back and forth in your work. So for this first example, we have the most variables on the right-hand side, so that side is going to be our variable side, and then that makes the other side our constant or plain number side. So we just have to make a decision about that before we start, and that's what we're going to go with for this example. So we write our original equation. We have that done for you in our guided notes here. And we have 5n minus 7 equal to 9n plus 21. Since the side on the left is our constant side, we want to get rid of the variable term on that side. And so we want to subtract 5n from both sides of the equation. And again, that goal for that is just to get all the variables terms to one side and all the constant terms to the other side. So we're going to subtract 5n from both sides. And you guys know from your guided notes before that they're writing them horizontally here. We would usually just write it underneath, but that 5n, that kind of plus 5n and the minus 5n here will cancel each other out, and we'll be able to continue. We bring down that minus 7. Notice that negative sign in front of the 7 comes down with that. And then we have our like terms on the right where we have 9n minus 5n, and we just put our like terms together, and that is going to give us 4n on the right hand side. And that's just combining our like terms, that's simplifying. Then because the right-hand side is our variable side, we want to get rid of the 21. And so we want to subtract 21 from each side of the equation. Always doing whatever we're doing from both sides of the equation. So we're going to subtract 21 from both sides of the equation. And on the right-hand side, our plus 21 and our minus 21 will cancel each other out. And on the left-hand side, we should get a negative 28. On the right-hand side, we're left with that 4n. And now this should look familiar to you. We've got constants on the left, variable terms on the right. But to get our variable n by itself, now all we need to do is divide each side by 4. And so we're going to take negative 28 and 4n, and we're going to just divide both sides by 4, and that gives us a negative 7. And so the solution is a negative 7. We'll write our solution set there, fancy algebra terms. So just as a recap, we want to choose a side for variables. The other side of the equation will be for constants. We want to get all the variable terms to one side, all the constant terms to the other side, and then we solve. So sometimes when we're solving, we have an equation with no solution. This is kind of what we call a special solution. And we follow the rules that we're supposed to do, but then something kind of still turns out a little different. So this one we have variables on both sides, but we see that we have distributing to do. We have to multiply that 3 times both terms in parentheses, but you have experience with that. So we're going to use the distributive property. And you take the 3 times the 2x, that's going to give us 6x, plus we also take the 3 times the 1, so that's going to give us 3. And so we get 6x plus 3 equals 6x. notice that this statement is not true, because the number 6x cannot be equal to 3 more than itself. I ran out of room there. I'll just write it underneath. There we go. 3 more than itself. So you can't have the number 6x and then add 3 to the same thing and have it be the same. So this equation has no solution. Again, when you get a value and it cannot be equal to itself, that has no solution. Now, we could continue solving. So we got 6x plus 3. If we wanted to get variables to one side, we would subtract 6x from both sides. So we can say, all right, subtract 6x from both sides. And we would continue, and that would give us 3. And then these two would cancel each other out, equals 0. And of course, the statement 3 equals 0 is not true. So again, when you get something like that, it means that the equation has no solution. Now that's when you're solving, not when you're checking, so just make note of that. And to show our solution, we can show either an empty solution set, kind of our fancy solution, or we could use the symbol for empty set, which is like a little 0 with a slash through it. So you could use one of those symbols. So example 3 is another example of a special solution. Sometimes when you solve an equation, all numbers will work. So it's not just like one number works, or like the last example that nothing would work. And sometimes when we solve, all numbers could work. So again, we have an equation here with that we have distributive, so we're going to apply the distributive property. You know you need to distribute that 4. So we would start with the 4 times x, which of course gives us 4x, and then 4 times the 2, which gives us 8. And then I hope that you notice that we have exactly the same thing on both sides of the equal sign. And so that any value of x is going to be the same when you're doing the same thing to it on both sides of the equal sign. So 4x plus 8 will always be true if it's equal to 4x plus 8. So that is a true statement. And this equation has every number as a solution. And we have a symbol for that, and it is like a capital R with a double bar on it. And that means all real numbers work. So moving on to the checkpoint, this is where we're going to practice. And we have number 1, 3n minus 6 equal to 5n plus 20. We do want to make a decision about which side will be our variable side and which side will be our constant side. And it doesn't really matter which. I usually like to look and see, okay, where do I have the most variable terms? I have the most variable terms this time on the right. So I'm going to make that my variable side, and I'm going to make the left-hand side my constant side. So that means on the left, I want to get rid of the variable term 3n. So I'm going to subtract 3n from both sides. The 3n plus 3n and minus 3n on the left will cancel, and I bring down the negative 6. Notice I'm bringing down that minus sign as a negative. On the right-hand side, I'm going to subtract 5n minus 3n, and that gives me 2n, and I bring down the plus 20. So now I've gotten all my variables together on the right-hand side. But also on the right-hand side, I have the constant 20. Well, I don't want the constant 20 on the variable side. So I need to subtract 20 from both sides. Those will cancel on the right, and I'm left with 2n on the right-hand side, and I am left with a negative 26 on the left. Now this part of the equation you should be familiar with. Think about what you would do to get n by itself. That's right, you would divide by 2, and you get n is equal to negative 13. Now we should check our solution. So I'm just going to make a little section here for my check where I'm going to write the original and then wherever the n is, that's where I'm going to plug in negative 13. And then I would plug those values into my calculator. I'm going to plug in the left-hand side and see what I get, and I'm going to plug in the right-hand side and see what I get. Now as I work that out, I get negative 45 on the left, and I plug in the right-hand side, I get negative 45 on the right. Since I got the same thing on both sides, it checks, and I know my solution is negative 13. So now we have number 2. Again, we have variables on both sides. We have some simplifying to do on this one. We have that distributive property. So we're going to take a look at that and do that first. On the left-hand side, we've got 12x. And on the right-hand side, we take that 4 times 3x. That's going to give us 12x. And 4 times minus 1, that's going to give us minus 4. Now you might notice right here, we've got almost the same thing on both sides, except 12x can't be the same as 12x minus 4. Now we could continue and we could get variables to both sides by subtracting 12x from both sides, but they'll cancel on both sides and we get 0 is equal to negative 4. Well, we know that is not true. So when our variables cancel out and we get a false statement, then that means we have no solution. For example 3, we've got distributive on both sides. So we'll just do one side at a time. So we're going to multiply 3 times 2n, that's going to give me 6n, plus 3 times the 4 gives me 12. And I've got my equal sign in between, and then 2 times 3n, 6n, plus 2 times 6 is 12. Now you should see that we have the same thing on both sides of the equation. When it's the same thing on both sides of the equation, that means all real numbers will work. So all numbers are the solution to this equation. For example, number 4, we've got variables on both sides. So we want to think about a variable side and a constant side. So it doesn't really matter which side. We've done the variable side on the right twice, so let's try the variable side on the left. So we'll make the left side the variable side and the right side the constant side. So if the left is the variable side, that means the plain old number or constant 7 does not belong. So let's subtract 7 off of that, and we have to of course do that on the other side to keep it balanced and equal. That gives us 2x on the left, and then on the right we have that negative 2x, and that would give us minus 20. Now on the right we have the constant of negative 20, but this is the variable term and we don't want that on the constant side. So we're going to add 2x to get rid of the negative 2x. And of course we do that to both sides to keep it equal and balanced. That's going to give us 4x on the left and negative 20 on the right. And then from here, you know that you need to divide both sides by 4 to get that x by itself. And we get x is equal to negative 5. Now because we got a number solution, we should check. So let's make a little spot to check. And we write down our original equation, 2x plus 7 equals negative 2x minus 13. And wherever there's an x, we're going to plug in the negative 5 that we got. So 2 times negative 5 plus 7, And we're hoping that's equal to negative 2 times negative 5 minus 13. I'm going to plug in the left-hand side into my calculator. So we get negative 10 plus 7 on the left, which gives us negative 3. Then we're going to plug the right-hand side of the equation into our calculator, and we're going to get 10 minus 13, which also gives us negative 3. There we go, negative 3. And we get the same thing on both sides. We know that we have the correct solution. So for example 4, we're going to apply this to finding the perimeter of a square. And we can't find the perimeter of the square until we find out what x is. But because it's a square, we know that all 4 sides are the same. If all 4 sides are the same, then we know that 3x has to be the same value as x plus 6. And that gives us our equation. So a square has 4 sides of equal length. That means we can write an equation setting those sides equal to each other. So 3x has to be the same as x plus 6. So we have an equation with variables on both sides. So once we've made the equation, in order to find x, then we go back to our decision making. Which side is our variable side? Which side is our constant side? Now I have more variables on the left this time, so I'm going to make that my variable side again, and the right constant sides. And since my left is the variable term, and there's only variable side, and there's only variable terms on that side, my focus is on the right. I want to get the variable term x off that side. So that means I'm going to subtract x from both sides of the equation. So whatever I have on both sides, I'm going to subtract x to get the variable off the constant side. So 3x minus x leaves me with 2x, and x plus 6 minus x just leaves me with the 6. So I have 2x on the left and 6 on the right. Now we know from there that we want to get the x by itself, we have to divide each side by 2. So I'm going to divide each side by 2, and we get that x equals 3. Now, all we did was find the x there, but remember the goal for this problem was to find the length, or find the perimeter. So now we're going to find the length of one side. We want to substitute 3 for x, because that's what we found that x was equal to. So let's put that into the 3x, and that means 9. To find the perimeter, we multiply the length of one side by the number of sides in a square, which is 4. So we're going to take the side measure 9, multiply that by 4, and we get the perimeter of the square, which is 36. So the perimeter of the square is 36 units. So we just used equation solving to solve a different kind of problem. So we're at a checkpoint and we've got the same kind of problem. We want to find the perimeter of the square. But in order to find the perimeter, we need to figure out what x is. But if we know in a square that the sides are the same, then we know that 5x is equal to 3x plus 8. So that is what we can write as our equation. 5x is equal to 3x plus 8. You try to solve this equation and enter an answer. Do your best, and then I'll give you the answer once your answer is entered into Edpuzzle. Okay, hopefully you got the solution. Let's see how it works out. I chose the left for my variable side again, and the right for my constant side. That means I wanted to get rid of 3x. So I'm going to subtract 3x from both sides. That left me with 2x on the left and 8 on the right. Then I divided by 2, and I got x is equal to 4. But I wasn't finished because I have to find the measure of the side. So I chose the side of the square, and I chose the side that was 5x. And I substitute my 4 in for x. That means the side of the square measures 20 units. And so 20 times 4 sides on the square, That means the perimeter of the square is 80 units. Is that what you got?